In this demo, we will learn how to prepare a grid file that has realistic topography and realistic coastlines. And it's basically a grid of a part of the world ocean. So in our home directory here, we go back into the ROMs grid where we have our scripts to help us prepare these grids. And to build a realistic grid, the script that you're interested in using is the main grid.m. So I'm just gonna run MATLAB first before I open that script. I'm going to exit here. Okay, so actually this is a good directory, so I'm going to run MATLAB. And I'm going to try, for example, to execute this script. You know, for example, if I did that, it would tell you that please manually step through this script. In fact, this main script, which I'm going to open now in this file here, vi, is actually meant not to be executed like that, but really you want to step through and execute by copying and pasting in MATLAB these things, and as you go through you will have to take some decisions. So for example, let's the first step of this demo is selecting the grid domain and the boundary, and create a boundary file that contains the information about the boundaries of the grid. So for example, in this case I'm interested in building a North Pacific grid per se. So I'm going to give it a name that is going to be a name that I want to use for my application, in this case N Pacific. Then I'm going to prepare set the name of the grid file, which is going to be this particular string N Pacific, and then I'm going to attach this grid.nc. And now I come here and I have to I want to decide on which coastline file I will use to select my domain. And here I have two choices. These are coastline files of the whole world. The first one is actually centered around the Atlantic. In other words, if you think of the longitudes are periodic around the world, and you can have various conventions. You can go from say minus 180 to plus 180, or you can go from 0 to plus 360, or from minus 360 to 0. Depending on where you do that, for example, let's actually make an example of this. I'm actually going to, in MATLAB, I'm going to execute these files. I'm going to load, for example, this coastline file that is centered around the Atlantic, F12. Then I'm going to create a figure here. And going back to the exec directory, I'm going to just plot this grid, for example. Okay, I'm going to actually draw, we're using this function, this particular coastline file. So I'm going to do F12. Okay, let's look at figure 1. So this is, for example, a grid file in which the longitudinal convention is from minus 150 to 150. Now this could be very handy if I'm doing grids, for example, in the Atlantic. Okay, but if I'm doing a grid in the Pacific, that's not very handy because now my longitude goes from minus 150 to plus 150, and so any plotting package or even your ROMS model is going to have trouble to go from negative to positive when really you should have a monotonically increased index in this direction. So to avoid that, then we, instead of using this convention, we can use a convention that goes from 0 say to minus 360, so that here everything is more monotonically increasing. To show you what I mean, let's go back here and select this other grid file, which is centered around the Pacific. And if we plot it now, and we look at the figure, now you find that the convention goes from 0 to minus 350, and so now I have all the Pacific in clear, and I can, here the indices are increasing monotonically from minus say 250 to 100. So I'm very happy with that. Okay, so the first step is then to draw the grid. The next thing that I'm going to do is I'm going to begin with just building, for example, a square grid, a very simple square grid. Now to do that, the first thing that I'm going to do is I'm going to zoom in my picture approximately to select the location of your final grid. So I'm going to go in MATLAB back here. I'm going to look at figure 1. I'm going to say zoom on. And then I'm going to go here, and now I have this zoom lens on, and I'm just going to select, for example, a grid. In this case, actually, I'm going to do it kind of carefully so that I actually select the grid that I want. Okay, and so now this is a grid of the North Pacific, say from minus 250 to 60. Okay, so I selected the area of interest in this case, and if that was actually the true coordinates of the grid that I wanted, then I can just grab those coordinates from the graphical window by just executing this piece of code. So I go back in MATLAB and I press that. And at this point, I can define the minimum and maximum longitude and minimum and maximum latitude of the four corner points. And I do that by doing this. So now I have basically the area of my grid. So let's go back here in the MATLAB, in the script file. The next thing that I want to do is I want to give a name to the file that it's going to contain the corner points of my grid. Okay, so I'm just going to go in MATLAB and execute this string here. Oh, I didn't define the variable out there, and that's because actually I don't want to do that. So I'm going to change this as we speak, and I'm just going to use it like that. So the corner file is going to be saved in this directory here. Okay, so I'm just going to execute this now in MATLAB F12. And if you see, the corner file is called gridcorners-n Pacific, which is the name of my application, .dat. Okay, so very good. So I did that, and at this point I have two options. If these are the true axes, okay, or these are true coordinates, okay, of my grid, meaning that I just have a square grid of that goes from longitude lon min to lon max and latitude lat min lat max, then I can just write the corner file, okay, and I'm going to do that. Okay, MATLAB. I'm going to do that, okay, and when I'm done, if I do a more of this file, okay, F12, I can see that I have here the the longitude and latitudes and so forth. These are it's a corner file, it's a grid, it's a boundary file that we will use later when we build the grid. Okay, so at this point, this is option 1. Okay, so I'm just writing basically these coordinates: lon min, lon max, lat min, lat max. And by the way, if you knew what those coordinates are, you could just edit them. You could just copy the string and just put whatever coordinates you want for the range in longitude and latitude. Now that's option 1, and so I'm going to skip now option 2, which is a different one, which I'll discuss in just a second. Once I'm done, I can actually plot my grid using this command over here. So I'm going to go here and execute it. And so now it's plotting, my grid, but it's using a Mercator projector that shows me basically it has equal distances in the x and y direction. So now this is actually looking more like the map of the Pacific, of the North Pacific. And you see that I have my grid file, my corner points are 1, 2, 3, 4. Okay, so in just a conventional term, this corner here is going to be the southwest corner, and typically the axis of the ROM's grid will originate from here, so it would extend. If you think of grid point number, the grid point number 1, 1 is over here, and then it goes in this direction and increases also in this direction. Okay, very good. So this is one possible grid. However, often you'll find the case that maybe you are building a grid that is really just focused on a particular region. Okay, suppose that you're really interested in a grid that is off British Columbia here. Okay, if that's the case, then we may want to have a grid that, instead of being a square in this region here, is actually a grid that follows the topography a little bit more carefully. Okay, so now I'm going to show you how to select a grid that is actually rotated with a certain angle with respect to the north-south, with respect to the geographic north-south directions. Okay, so how do we do that? Let's go back in our script, in our MATLAB. And so this would be option 2. If you already have a corner file, then skip define grid corners. Use this routine to design grid if needed, meaning in this case if you want to do a rotated grid. So I'm just going to select this. Well, first of all, I want to start all over again, actually, and I want to start by drawing the grid. Okay, so I'm going to go back here and do mfig, and I'm going to draw the grid here. Then I'm going to say zoom on, and I'm going to go in the approximate location of where I want to draw the grid. In my particular case, I want to draw a grid off British Columbia here, so I'm just going to roughly just select this area, okay, just so that this is the area where I want to more or less work with my grid. Okay, so once I did that, then I go back to my my script here, and I just execute this stuff here. So I'm just doing this again, F12. Then I'm going to go down, and as I said, instead of writing the grid the corner file, I'm just going to build a new type of corner file, which is rotated with respect to a thing. And I'm going to use this routine that's called find grid corners to do that. So I'm going to press this. Okay. So now what this does, it's very nice. It just plots, the area that I selected in a Mercator projector, and then it asks me to draw a rectangle and rotate the rectangle in the locations where I want the grid. So for example, I'm just going to start drawing a rectangle here. Okay, approximately like that. And now draw the rectangle around. Now scale it by grabbing the corners, meaning that if I go here, I can change the size of this thing. And then I can rotate it pressing the Control key. So I go here now, and I can rotate this, to make it to come, more or less, where I want. Okay, so here you see I'm just selecting this particular, piece of ocean. Okay, maybe I want to extend and do the whole Gulf of Alaska, say. Okay, so I'm just going to go right here, and then I'm going to elongate this grid like this. So for example, now I did a grid file, I prepared a boundary file, for the Gulf of Alaska here. And note that this is a little bit more convenient sometimes than just having, for example, a square grid file. For example, if I just had if I just followed the north-south direction, I would have something that looks like this, for example, and it may not. For example, if I do that, see if I did this grid, for example. Okay, and you could see that I have a lot of land over here. Okay, and so by rotating the grid, I can better follow the topography and minimize the number of land points, and so that's why we typically do that. Now this may not be the perfect example. Now I have to redo it a little bit. Okay, so I'm here slowly trying to make this as best as I can. Okay, so you can kind of convince yourself that by doing this, I've minimized the number of land points and maximized the number of oceanic points. So once I'm done with this, I double click here, and on my MATLAB window it'll tell me select the northwest corner. The northwest corner in this case is going to be north. This is the north of the grid, and this is the west. So this is the northwest corner. So I just have to click there approximately, and that will be fine. Then it asks me to select the southwest corner, which is down here. Okay. Then the southeast corner, which is this one, and then the northeast corner, which is this one. Okay. Once I'm done, this is done, and you can see that here says I wrote the grid corner file. So I can close this now. And if I go back to my MATLAB window, okay, I can now plot, the new boundaries of the grid. And now you see that, in fact, we have those corners. And so now we have stored and computed those corners. So this is an alternative way of creating or selecting the boundary files for a grid that is not just oriented in the north-south direction, but it's rotated of a certain angle. Now, these two approaches, of course, do not follow exactly. For example, this grid is still a rectangular grid. It's just rotated, but it's not following per se the topography or by using some kind of more curvilinear, coordinate of the grid. And if you want to do like grids that follow the topography very closely like this, and that's something that you can do using, for example, a Cgrid software, which we'll still use in the next demo. But for now, we're just going to learn to draw rectangular grids either in the north-south direction or rotated of a certain angle to better kind of follow the coastline. In my experience, these types of grid are typically kind of useful enough to do most applications. So if you're a beginner, this is plenty. And in fact, I never really created grids that follow the topography with a very kind of roundish shape. Okay, very good. This is all for this demo.